All right. Welcome everyone to our fourth session of the Science Writing Internship. And today we have another very exciting speaker with us. It's Maheera Abdul Ghani, and she is one of the advisory board members of Scientia as well. She has done her PhD from Cambridge in material sciences, and her expertise lies in the field of nanomaterials, 2D materials, and nanoelectronic devices. She is also a policy writer at Cambridge Zero for sustainable carbon storage and a co-founder at WinSci Pakistan, an organization that is dedicated to promoting the participation of women in STEM. Today, the topic of her session is communicating science and the world of material science engineering. And I hope that you all will eagerly listen to her. And if you have any questions, feel free to ask it during the later part of the session. Over to you, Maheera.
Firstly, hello to everyone. I cannot see everyone right now because I'm in presentation mode, but I would like to take questions from everyone at the end of this presentation, and I want it to be very much engaging. So I'll talk about communicating science in the world of material science. And firstly, I'll just start with my own basic introduction, my background, and what I'm doing right now. I did my undergraduate studies in material engineering in Pakistan, and then I did my master's in Germany and France in advanced material engineering. And since then, I have moved towards PhDs since 2021, and till 2025, I completed my PhD viva recently. I do work with a lot of startups in terms of technology. And currently, I'm starting my own technology work, and I'm still working at University of Cambridge. So coming to my research background, maybe you are all from different levels, but I would just like to put out there that right now, a lot of researchers in material science are working on two-dimensional materials, and you can see here what a two-dimensional material is. There are different material out there which are 3D bonded and 2D bonded. So my research is based on layered material. So you can see there is one layer of material and another layer of material, and these can slide over each other. So these materials are bonded together by van der Waals forces. So we know there are three different kinds of bondings: ionic, covalent, metallic, and van der Waals, four. So they are all interacted through van der Waals forces. And my research was to explore these materials for electronic devices. And I made different kind of electronic structures, and I measured their interfacial effects. So that's my research expertise and area. So moving on forward, I would like to share that what are our topics that I want to cover. And it is important with respect to your workshop or your training right now with Scientia magazine as an intern. So this training for you is to understand when you are learning about scientific writing or science writing as a scientific communicator. So there are a lot of things that you have to understand that should be reflected in your writing. आपकी राइटिंग में वो रिफ्लेक्ट होना चाहिए, चाहे वो कहीं से भी पढ़ा जाए, चाहे वो कहीं भी आर्टिकल पढ़ा जाए, तो उसमें क्या सबसे ज़्यादा इम्पोर्टेंट होता है. So I will start from the basic actually, how people have communicated science through ages. Science communication actually became very important recently, we think, but it has been out there since classical era. We have seen development of texts and manuscripts as a tool for recording or sharing knowledge. And this used to happen back then, you can say, before this, before I think 11th century or 10th century, people still used to record it. तो उसके बाद ये कि एज ऑफ एनलाइटमेंट जिसको हम कहते हैं 13th century के अराउंड 15th century के अराउंड द वर्ल्ड academics or societies जो हैं वो इकट्ठे होने लगी, and they felt the need to talk about science within themselves. और but उस वक्त तक फिर भी within general audience in public the science communication was not there. और science journalism जो है वो ज़्यादा 19th century में established हुई, जब people started to do seminars of their research and wanted to give idea of this to general audience. और इंटरेस्टिंगली साइंटिस्ट की टर्म भी इससे पहले नहीं थी. साइंटिस्ट की टर्म भी मोस्टली 19th सेंचुरी के बाद ही आई है. एवरीवन यूज्ड टू बी फिलोसोफर बिफोर. So now we are in this point where we have the diversity of communication channels, platforms, YouTube channels, and everything. But we also have another crisis now, that is misinformation that goes around. I think once the information is out there in public, the way public perceives it is different than a scientist or scientific community perceives it. So misinformation or fake news जो है digital age में, it becomes very much high. So we are in a different stage and a different challenging point. So if you are going to be in a scientific communication area field, आपको कुछ चीज़ों का बहुत ख्याल रखना पड़ता है, especially for now. So for example, you say we all communicate, the way scientific communication is about carbon footprint or AI or carbon dioxide emission is different. The understanding is different in scientific communication. लेकिन जब आप public understanding देखते हैं तो वो थोड़ी different होती है. Still we know public is not there yet on climate issue at the same page, or whether it's carbon footprint. So how it just tells you कि किस तरह scientific information बहुत important है अब, और सही information बाहर लेके जाना कितना जरूरी है. So there are different loops कि आप किस तरह काम करते हैं. Mostly what happens is scientists who work around the lab, they work on science, but they might not share it with people outside. फिर साइंटिफिक कम्युनिकेशन होती है जहाँ पे आप डिफरेंट एजुकेटर्स, इंडस्ट्री पार्टनर से बात करते हैं जहाँ पे वो साइंस रेलिवेंट होती है, एंड देन यू टॉक अबाउट दिस आउटसाइड योर ओन वर्क एंड लैब. और उसके साथ साथ यू हैव अ चांस कि इफ यू हैव गुड स्किल्स टू टेक योर साइंस आउटसाइड द लैब, you can share it with different audience for different technology, or to help them, for example, medical news or anything. So then इस case में वो बहुत helpful रहता है. So what can you do as a science communicator? What are the steps for you to think? So अगर आप कोई भी आर्टिकल देखते हैं या कोई भी आप न्यूज़ पढ़ते हैं, जो पेपर है, लिटरेचर रिव्यू का कोई भी, तो आप उसमें कुछ चीज़ें पढ़ते हैं कि सबसे पहले I think you have to identify as a reader and as a researcher also कि why would anyone care about this in a public? For any person like me or anyone, साइंस तब तक हेल्पफुल नहीं होती जब उनकी रियल लाइफ में कोई इम्पैक्ट ना क्रिएट कर रही हो या कोई चेंज ना क्रिएट कर रही हो. तो यू हैव टू नो अबाउट हाउ इट कैन क्रिएट एन इम्पैक्ट एंड मेक अ लिंक. तो एज अ साइंटिस्ट ऑल्सो आपका सबसे बड़ा चैलेंज यही होता है कि आपने एक पब्लिक और जो एक जनरल ऑडियंस है उसको रेलिवेंट करना है, और व्हाट कैन दे लर्न फ्रॉम दैट साइंस एंड हाउ डज इट अफेक्ट देयर डेली लाइफ. For example, if I should take care of this thing for my personal health, I should know it from a scientific paper, and someone who is telling me should tell me in that way. So इस तरह आपकी जो communication skills हैं वो scientific literacy से relate होती है public के साथ. तो ये चीज आई थिंक ये 3 क्वेश्चंस जो होते हैं किसी भी आर्टिकल में आपको बहुत इंपॉर्टेंट होते हैं. इट मेक्स योर स्टोरी वेरी रेलिवेंट. So because the communication part of science is all about science communication, so it's very important to take care of these steps. Like for example now, what do science communicators mostly communicate? So इसमें for example, like अगर आपकी भी यहाँ पे as a role you're writing an article, you are a writer, you will look into specific research or some grants or some these kind of like news. आप health issues, disease और disorder से related काम कर सकते हैं, new technologies पे, or new opportunities for science jobs, especially in STEM fields. So as a communicator, if you need information from out there in the world, you go to these research websites और आप उनसे information collect करते हैं. उसके अलावा there are a lot of websites which publish the summaries of all of these papers most of the time. So you can look into the published summary review letters जो कि बहुत easy होते हैं पढ़ना, जो कि less scientific language में होते हैं, and you can translate and relate to it very much easily. So firstly, I would always start is that whenever you are writing or trying to educate a public, you have to make a very, very simple story that can be translated to them. So for example, सबसे पहले आप जो चाहते हैं, आप पब्लिक को अगर एजुकेट करना चाहते हैं, you have to understand yourself कि वो एक साइंस के बारे में क्या बात कर रहे हैं, और आपको उसमें से स्टोरी इस तरह कंस्ट्रक्ट करनी है कि वो एक बहुत ही ट्रांसपेरेंट और बहुत इजी कम्युनिकेशन में लगे. You are trying to make science more transparent, especially with government issues and everywhere. I'll have my laser pointer on. So you want to make science more transparent, and you want to address issues which are kind of big. So issues like we are having right now are AI is going to replace our job, and how is AI changing computing? How is AI changing different world? This is kind of an urgent issue, but there are also urgent issues in medical sciences. For example, what is going to be the next pandemic, or how are we going to treat vaccines, or what kind of innovation is happening, and then to inform and educate companies to bring innovation to market. इसमें ये भी होता है कि sometimes you do not want to target public. Sometimes आपका जो काम है वो company या startup owners हैं वो भी देखते हैं, and you bring the information forward to them. So to educate decision makers, जो कि पॉलिसी मेकर्स होते हैं, उनके लिए भी बहुत इंपॉर्टेंट होता है कि आप ऐसा इंफॉर्मेशन आप बाहर रखें कि वो जो है उससे इंफॉर्मेशन लेते हैं. So overall, your scientific research or scientific communication research is very important to all of these different sectors. You never know which you are going to help in many way. If you're writing for Scientia magazine in Pakistan, a lot of people might be getting a lot of benefit from what you're writing. So just some simple or very basic ground rules to start with. First, of course, I mentioned that you need to have an idea of storytelling. कि आप अपनी story किस तरह से बना रहे हैं. You have to develop a need, you have to develop an audience, and then you have to make a story to make a connection. बट ओवरऑल एक और भी बहुत इंपॉर्टेंट चीज़ है कि जो हमारे साइंस कम्युनिकेशन में चैलेंज होता है वो होता है टेक्निकल लैंग्वेज बैरियर का, कि हम अपनी लैंग्वेज को इस तरह से चूज करें कि हम साइंटिफिक इंफॉर्मेशन भी कन्वे करें लेकिन बहुत टेक्निकल टर्म्स ना डालें. सो ये एक बहुत बड़ी स्किल होती है अगर आप अपनी स्टोरी टेलिंग को बहुत ईजी कर दें. और ऑफ कोर्स आपको इस तरह से करनी होती है बहुत बैलेंस्ड कम्युनिकेशन कि जिसमें आप अपना opinion, your point of view कम present करते हैं, but rather what is happening in scientific communication, you communicate that. So this is a difference between policy makers और जो social sciences में काम करते हैं, they present their opinion, historians, they present their opinion, but as a scientific communicator, you present what is science out there because you cannot change that. So misinformation उससे ज़्यादा फैलती है. So you have to take care of that, and of course cultural and societal differences in understanding science. So people in Pakistan perceive science or some kind of different principles might be possible that they do not understand what you're talking about. तो आपको एक बहुत ground reality में जाके काम करना होता है. तो we have seen people, like I have seen articles, some in Pakistan also, they're very well written, catering to the needs of Pakistani community. और जो मोस्टली चैलेंजेस आते हैं कि फॉर एग्जांपल इन पाकिस्तान we have almost limited access to scientific information, mostly in communities. We do not talk or engage much in Pakistan, which is still a big barrier that we have to overcome as compared to certain communities, but it's still not bad. So we are still working on it. तो हमने अपनी information को इस तरह भी engage करना है कि वो उनके लिए exciting भी लगे. So what are some of the strategies when you are writing any article or communicating science? What do you need to start with? So first you need to focus and start from knowing your audience कि आप किस तरह अपना मैसेज जो है वो टेलर कर रहे हैं. आप अगर पाकिस्तान को टारगेट कर रहे हैं तो आपको अपना मैसेज को थोड़ा लेवल ऑफ अंडरस्टैंडिंग चेंज करना है. आप उर्दू में लिख रहे हैं या इंग्लिश में लिख रहे हैं, आपको अपनी लैंग्वेज को देखना है कि किस तरह उर्दू में मैसेज कन्वे हो रहा है या इंग्लिश में हो रहा है, और उससे वो आपकी जो चीज़ है वो बहुत इंटरेस्टिंग हो जाती है. Although you can write in English for any article, it can be work for Pakistan also. But the thing is, knowing your audience also means, are you writing for people who are industrial experts or policy makers or general audience? तो ये भी जानना बहुत ज़रूरी होता है कि आप किसके लिए टारगेट कर रहे हैं. आपकी लेवल ऑफ साइंटिफिक इंफॉर्मेशन वेरी कर सकती है डिपेंडिंग ऑन डिफरेंट पीपल, तो उसको जानना एक बहुत ज़रूरी होता है. उस केस में आप समरी बना सकते हैं कि व्हाट काइंड ऑफ language would my people would want. Or second most important thing for me personally is always storytelling, making science relatable, engaging in a certain narrative. तो इसलिए ये बहुत इंपॉर्टेंट स्किल है जो कि बहुत मुश्किल से मुझे लगता है यू ट्राई टू लर्न अबाउट इट इज बिकॉज स्टोरी टेलिंग इज समथिंग कि आप खाली बता किसी चीज़ का जिक्र नहीं कर रहे लेकिन आप उसको इतना एंगेज कर रहे हैं एक नैरेटिव की तरफ। आपकी एक स्टोरी का एक थीम है, व्हाट आर यू राइटिंग, और ये आप लर्न भी करते हैं ड्यूरिंग योर ओन पेपर्स पब्लिश। जब आप रिसर्च पेपर्स पब्लिश करते हैं तो सबसे पहले जो चीज़ होती है आपके लिए वो यही इंपॉर्टेंट होता है कि व्हाट स्टोरी डू यू वांट टू कन्वे। आपका ओवरऑल एक वन लाइन मैसेज क्या होगा। फॉर एग्जाम्पल इफ आई एम राइटिंग अ पेपर ऑन 2D मटेरियल फॉर इलेक्ट्रॉनिक्स, तो मेरी उसमें स्टोरी टेलिंग यही होगी कि मैं ये एक लाइन में कन्वे कर सकूं कि 2D मटेरियल्स अब यूज हो रहे हैं इलेक्ट्रॉनिक्स के लिए और ये प्रॉमिसिंग है। गोल मेरा ये है और उसमें मैं साइंस को यूज करूंगी और उसको एंगेज करूंगी। तो स्टोरी टेलिंग जो है मुझे लगता है कि इज biggest skill you can have in communication of any kind of research or a science article. Next comes your visual or multimedia aids. So enhance your comprehension of graphics and videos. So what happens is that whatever visuals that you use are always very helpful. You have to choose them in a way that they are kind of very much related to your text and how people can get help from them. And of course, at the end, the transparency and honesty, acknowledging कि जो limitations हैं इस काम की और किसे बेहतर हो सकता है, और इसके अलावा जो रिसर्च आपने यूज किया उसको एक्नॉलेज करना कि कहाँ से मैंने ये रिसर्च ली है और मैं उसको किस तरह एक्नॉलेज करती हूँ। सबसे बड़ी बात एक जो अब बहुत इंपॉर्टेंट ये भी है कि nowadays a lot of people around the world are looking into ethical standards in communication. Ethical considerations are very important. These are the aspects जो आपके साइंटिफिक नॉलेज के अलावा टेक्निकल सेक्शंस के अलावा डील करती है आपकी कम्युनिकेशन से, such as avoiding too much exaggeration या सेंस या उसको बहुत ज़्यादा सनसनी करके या उसको बहुत ज़्यादा hyped करके present करना more than its own potential. So that is a part where it becomes bit problematic for science communicators कि जहाँ scientists बहुत care से एक चीज़ को present करते हैं वहाँ communicators might exaggerate it more than it should be, and it creates some kind of misinformation. Then, of course, comes the part of ensuring your accuracy and integrity in reporting scientific information. This includes citations, references that you have used, putting them very much together. You should take care of citing the exact articles जहाँ पे आपने use किया है और उसकी information भी कैसे आपने बहुत अच्छी तरह present करनी है. Right. And next, of course, again, respecting diverse perspectives and cultural sensitivities. For any communication, you have to always respect that आप किसी certain community को आप उसको engage करते हैं, ज़्यादा आप उसको disrespect नहीं कर रहे और you are taking your message out there. And addressing conflict of interest and potential bias in communication. So it means कि अगर for example आपने कोई चीज़ present की है और अभी वो 100% sure नहीं है और उसमें researchers are presenting some other point of view as well, तो वो भी आप at the last paragraph you can cover that up. So what the thing is that in science all the time conflict of interest exists करते हैं, potential bias exists करता है. You have to put your writing in a way कि might be possible कि जो science मैंने present किया है it's very good but it's not there yet. So big part of science is just exploring. So nothing is conclusive right now. So you have to kind of ensure that in your science that this is something that is still ongoing but we have not seen anything yet. So वो आपके एक authenticity को एक further एक polish करता है text को. So again, I give this example कि scientists discovered a vaccine. So अगर आप उसको बहुत exaggerate करके present करते हैं that scientists discover cure for all diseases, this is an example of a bad science communication. It shows it lacks specification and it is very much essentialized. और एक exaggerated language use कर रहे हैं broad claim में. It might not be true, this new vaccine can be good, but it might not be for all diseases. But just for the sake of attention, you cannot give a misunderstanding, a false hope, and this will सबसे पहले this will undermine your own scientific language. And this is what we also teach in our PhD, in our research groups also. Okay, you have to take care of any claim that you're making in science should be very much relevant and lack exaggerations. So another example for you can say that researchers in XYZ's university have identified a novel antigen for an immune system against malaria. So this breakthrough offers hope for the future malaria prevention and control for the testing. This is an information that is in a paper. So recent studies have shown a promising result in development of potential vaccine. So basically what this shows is कि वही जो एक रिसर्च मैंने आपको बताई है उसको किस तरह दो तरीकों में बताया गया है. पहली ये एक हेडिंग है कि साइंटिस्ट डिस्कवर क्योर फॉर ऑल डिजीज, न्यू वैक्सीन फाउंड, रीड ऑल अबाउट इट. Second is a similar heading for the same vaccine that recent studies have shown promising results in development of a potential vaccine for malaria. So you can see the difference in headings. दोनों जो है एक ही टॉपिक को कैटर कर रहे हैं, लेकिन एक जो है वो कितनी ज्यादा स्पेसिफिक और कितनी ज्यादा ऑथेंटिक लग रही है. So basically this is how you have to put your research in a very composed manner out there. So in a material science basically इस वक्त जो है वो communication बहुत important हो चुकी है because we see a boom of materials everywhere for electronics, for AI and everything. So this is a branch that is like informed in different sectors. So for example, like अब material science की बात करते हैं तो वो mechanical engineering है.
Yes. I think since we are having since now we are getting into the second part, I think there is a question. Can we take right now?
Yes, we can take question.
Okay, and secondly also the question is so you talked about curating your writing according to targeted audience, whether it is policy. Okay, yes, please ask. I think question is without please you can ask your question.
Sorry?
I'm asking to the intern. Intern, you need to ask. There is no question within it. You need to ask.
Assalamu alaikum. So my question was basically that Maheera just talked about how we have to curate our writing to the audience, like whether it's the policymakers or the general audience. So what if our article or writing is, for example, it's about a public health issue, and we want the audience to also to understand and get aware of the problem going on, and we also want policymakers to take note of that. So how should we like go about it? Like, should we use technical terms in that or just general writing?
So in that case, what you do is कि आप पहले तो आप एक general story create करते हैं, but then again, if you want it to be targeted to policymakers or industry, आप एक दो पैराग्राफ्स ऐड करते हैं जिसमें आप थोड़ी टेक्निकल टर्म्स यूज कर सकते हैं. तो अगर आप कोई भी साइंटिफिक कम्युनिकेशन आर्टिकल्स देखें, दे हैव आई थिंक 5 to 6 पैराग्राफ्स, जिसमें से फर्स्ट जो होता है एक जनरल इंट्रोडक्शन होता है, सेकंड में आप थोड़ा इन डेप्थ जाते हैं, और थर्ड और फोर्थ जो होता है वो टेक्निकल इन डेप्थ टर्म्स रखता है. तो अगर आप चाहते हैं कि फॉर एग्जांपल यू आल्सो वांट टू कम्युनिकेट दैट कम्युनिटी, तो यू माइट एंड यू कैन हैव few 3 or 4 technical lines or terms आप उसमें यूज कर सकते हैं पब्लिक के साथ साथ, क्योंकि पब्लिक में भी there would be a lot of people who are जिनके नॉलेज वेरी करता है अंडरस्टैंडिंग के बारे में, तो वो आप उसमें ऐड कर सकते हैं और बहुत ही बैलेंस तरीके से कि आपका पूरा आर्टिकल उन पे ना टारगेट हो जाए. यू कीप इन माइंड कि पब्लिक के लिए भी है और उनके लिए भी है. तो व्हाट नॉर्मली हैपेंस कि इस तरह के आर्टिकल्स में 5 to 6 पैराग्राफ्स जो होते हैं उसमें से थर्ड और फोर्थ जो होता है वो आप थोड़ा टेक्निकल रखते हैं, और फिर जो एंड पे 5 or 6 होता है यू मूव टुवर्ड्स कंक्लूडिंग योर समरी ऑफ द वर्क.
All right, thank you.
Okay, one more thing. There is another question. Just before I need to give you a pointer. Two of our participants are international, one from Egypt and one from somewhere else. So I mean, I was thinking if we not go bilingual, we don't have to go bilingual. However, it's convenient for you. Okay. So the second question is, what go for you? from where can we get authentic data for research analysis if we don't have accessible links to acquire data from institute like hospital and onwards? I mean, what are the sources? Mariam has asked this question.
For authentic resources, एक तो research websites होती हैं जो कि कुछ open access papers publish करते हैं. So most of the times, most of the time, what happens is that your research articles are published in one journal and they're not open access. So what you mean is it's not open access. It means you have to pay to get the article. But in case you can't do that, there are a lot of articles who also do open access. So you can go there and search for open access articles, and there are always database around that include information of medical information or any new health related news. There are a lot of medical journals who actually I think there are some journals such as PubMed or some other journals that I can't come across, but they have some open articles and you can use their information. But then another thing is that if you feel like you really want to know about information, what you can also do is that if you have university access through some of the research sites, I hope you have. But if you have that access, that also helps you get the information. For your university also pays for access to some journals, and then you can have access to that. But I would say it is still tricky to get information because nowadays the research is not really free all the time. So this is a challenge, I would say. The only thing I can say is that get your information most out of what is there out free on the websites.
Okay. Could we also directly ask those scientists, those people directly, are they willing to share the access?
You can ask the scientists to share their paper that you like. They can share, you can request that I do not have the access, can you share? It might be possible they can, but most of the time the problem that happens is everyone is mostly very busy, especially scientists. So what I have heard is it's difficult for them to get back to you. There might be a lot of people asking them and they might not find it very important. This is one aspect you have to face, but you're always welcome to ask them. And also if you're on ResearchGate is one of the research websites. It has a lot of papers online that you can download and view. A lot of people put their papers there as well. And you can also request their papers on that website. So I think you can ask, but then again, like, it's not necessarily that you will get a reply from them.
Okay. Well, there are 2-3 more questions. Would you like to answer now, or let's get on to and we can have the proper session?
Yes, I think we can discuss at the end also.
Okay, yeah, sure, please. Okay, we will answer the question by the end. Let's continue. Thank you, Maya.
No worries. So in this session, I was going to talk about materials for different directions, right? Materials for physics, chemistry, biomedical materials, and a lot of different directions. So there's a lot of good area for any researcher or any public communicator to look into electronic devices or electronics, how materials are changing the world. Where does Pakistan lie, or whichever country you are from, in their positioning of using materials for electronics in terms of industry. So, for example, one very important issue with with electronic companies are data storage and energy consumption. This is something that a general audience or public is not much aware of. There is high demand of data storage right now, right? We're using a lot of different kind of apps right now. We're using a lot of phones right now. So what happened, when you use a lot of these devices, it increases the demand of electronics, and semiconductors, which are one of the important devices which are used in electronics, are continuously improving themselves. But still, we are very much not closer to low power consumption. People have reported fires at data centers because of this issue, and it is becoming very big. So this is something we have to cater, such as also that you can see that the demand of total electricity for information technology is much more. And also the carbon footprint that comes with this demand is also very high. So it's nearly higher than the air industry as well. So this tells us that how much lack of information is there out for this kind of issues that is being catered. And for example, if you see here, the blue part is for the data centers where you store all the information from your apps like Instagram or Facebook. And then there is different other parts which use the carbon. So it shows that how much carbon dioxide is also produced in this process and have an effect on people and also on the overall community. So since my research is on 2D materials for future electronics, I just shared briefly, I gave an introduction in the start. So my research was, of course, to understand the electronics paradigm right now. As you can see, this is a structure of a wafer device that make different chips. And as you see, different years, this value of transistors is increasing from 11 billion to 19 billion transistors. So now electronics are getting so smaller and smaller, but you can see that how much smaller scale we are going. So my materials, the one that I work on, are made to work in different directions. I work on these materials which are very thin in layer, and you can actually just peel them off. They're atomically thin, and then you can make different applications from that. As you can see here, it's an example that how a bulk material looks like, for example, any bulk material, and how the 2D material that I've worked with looks like. So there are different physical parameters that makes them very different to each other. And this is how you can make different electronic or photonic applications with these materials. So I'll end my talk here, and then I would like to take questions from everyone now.
Okay, so the questions we have in pending. Could you share any tools for making visuals when we are communicating? The question. Any tools you would like to recommend?
1 second. Can you share it again?
Maheera, he has asked, could you recommend any tools for making these visuals when we are communicating?
For tools, I think, for example, if you're making visuals, I honestly still recommend PowerPoint. PowerPoint is very much easy. You can actually tailor your any visual in that. But other than that, I believe everyone is aware of Canva. I think Canva is a website that can allow you to put different tools together. Canva say you can also export to PowerPoint, and PowerPoint where you can make this visual. So I always prefer to make visuals myself in PowerPoint. They're much easier, and I can make images very simply. You can also go to more advanced tools as well, but I don't think that's very important. Things that are mostly kept more simple is much better.
Amazing. Another question is there. As a cancer researcher, I struggle to convey my research because I feel like it leads to so many things that I can explain to, which also leads me to question whether people are reading this in the first place, especially since these days people are more inclined towards short form of content like Instagram and YouTube shorts. So what do you think, Ajay?
Okay, maybe I should read this question myself.
Yes.
Sure. So can you please put this question together again?
Question by Abir Asif. Could you see, or I could say on again?
I'm trying to see where the questions.
Okay, that's all right.
I can talk about it.
Yes, please ask.
Sure.
Yes, please ask. That would be better.
Okay. First of all, thank you so much for the talk. And secondly, I feel like because my research is in such a niche area, it's just like explaining even one topic leads to me having to explain like 10 other topics. And how do you like communicate your research when you're not even sure people are reading it? I mean, like the overall impact of it and stuff.
Right. So I think this is something that a lot of researchers struggle with, to convey your research um, that has a lot of different branches. But then again, I would like to ask you to think in a way that your research must have one specific goal at the end. They would have there must be a lot of different directions for your research, and this is how any research is, that you are working on cancer, there would be a lot of different directions, but you need to take uh, this point into mind, that there is one thing that is very important to the people. So you have to start with that and keep your story limited to that. Now, for example, I work on 2D materials for electronic devices. There are a lot of different direction I can talk to, but I try to put it in a very simpler terms, because over years and years, I have tried to polish my version that is easier for people to understand. So you also look into your cancer research, okay, how it is related to public audience. So I know you asked that people are more inclined to look into the content from Instagram and YouTube Shorts. This is true, but if you see, like, your cancer research can actually make a lot of YouTube Shorts and content, because there will be a lot of tiny, tiny things that you know and public don't know. So maybe you need to think about in a very simpler way. Okay, what are you helping with your cancer research at the end of the day? Why do you are working on it? So this is a question that you have to think and then put it in a very, very simpler way. I think your research is 99%, and your scientific communication or public communication is 1% of your research. So you have to put it in a very, very simpler way.
Okay. Yes, you can ask the question, Sai.
Hello, Mahira. Thank you so much for having this session. My question was that you talked about a lot of misinformation online and that there's a lot of content available, but we don't really know if it's accurate or not. So, what are the factors we should consider when carrying out something like a literature review and checking whether our sources are actually credible or not?
Right. So what happens is, it's possible that you have not all the access to the information, and information out there is also not accurate. A good thing to do is to have 2 or 3 papers which show the same trend. Then you can agree on that. So a very balanced way to move forward is that you can present that recent studies have shown this. Recent studies have shown a new vaccine that can treat malaria. And then in the text, in your paragraphs, you can say, while this is an ongoing research shown by these 3 articles, there is still research needed to go on to find these answers. So you have to make it very much balanced and say this again and again, that this is not the end result. People are still working on it. We are not sure about it. One part of scientific communication is that you're not trying to tell what is the biggest innovation and what is the biggest cure. You're trying to tell what science is debating on. Like, for example, graphene is very good material for electronics, but some researchers do not think like that. So your public communication is also important to convey that debate. So you have to focus on that debate, that this debate is going on and I'm trying to work on it. Like, graphene is an overhyped material. Is it going to fulfill the requirement for electronics? This is your question. It's a debate. So most of the time, you just do not need to communicate a good research, but a debate as well. So this can go for any topic as also.
Okay, thank you so much.
Okay, Bushra, you can ask the question now. You have raised your hand.
Yes. Okay, first of all, thank you so much, Dr. Maheera. I'm finally talking to you. You're my biggest role model here. So this question is basically related to something personal. So I am related to a rural Sindh area, and there the biggest problem we face here is genetic disorders. So the reason I got interested into material sciences, nanotechnology, and biomedical engineering was to see how much this new technology can help us reduce the cost or like increase the accessibility of tools like genetic screening type of tools. Like, how can we use this technology, and to what extent can, like, I'm in A levels right now, so like for my own mindset, like how much can we use this technology to reduce the cost, and how feasible it is exactly?
So if you're thinking with respect to materials for genetic disorders, This branch would be something that is related to materials for life sciences and materials for biomedicals. Um, there must be a lot of interest in this area because I'm not sure about genetic disorders, how to treat it, but I think uh, the cost comes from the equipments, the medical equipments, medical facilities that you use. For example, MRI scans use a lot of materials for MRI, body check. So if you want to cater to something that is related to genetic disorder, there might be a lot of scientific or medical equipments or machinery that goes around treating these genetic disorders. For example, machine where a human body goes inside, what kind of materials people are using in that. You can learn about that, okay, how people are using that and how you can try to improve it. Honestly, another aspect is that a lot of people who have little bit idea of material science also go towards nanoparticles and life science research to treat these genetic disorders. But that become more like a medical field. You can look into biomaterials that goes inside your body and how does the certain medicine reacts with your material. But then again, then it needs a lot of idea of medicine also. Like if you want to work on material science in this aspect, you need to also learn lot of medical stuff as well. So you can know about materials in this area by looking into external materials that are linked with body and internal materials that can go inside the body and how people can make it less costly. There's always a challenge to make things less costly with materials. So there has to be a lot of research done to conclusively go on that. So I would say that reading some papers around it, how material science is helping genetic disorder, biomaterials as a start, you can try to look into it. It's an interesting topic. Anyway, it looks very interesting. So you can try to read about it, learn more about it, and what is in context with Pakistan right now, the situation. That would be a good thing to go towards.
Okay, thank you.
Okay. Now we have a few questions in the chat. If you could see, is it available or from
Yeah, I can see, but which one is this?
Khala Batul's question?
Okay.
You can take it from there.
So you asked that, Hola asked that writing a recent article, should it focus solely on reporting the facts or important to include public reactions also? So it totally depends on you as a communicator. Like I just mentioned that, are you catering to a debate that is going on around that subject, or are you here to inform that? This is your choice. Which one can you convey it better? I read a new article. I find it very interesting. Should I share it with people or should I share what people reaction are on it? There are two different articles you can write on it. And secondly, if you think that, for example, you have read this one paper and then one paper actually sometimes is not very conclusive. As a researcher also, we know that having one scientific paper on one discovery is not a very good thing. You need to have 10 or 15 paper that can show the same thing. So after you read 10 to 15 paper, you can report the fact. And then at the end, if you would like to add, you can say that this is still not conclusive. People are working on it. So I think this is a very balanced way to move forward with such kind of scientific writing.
Okay. Another question. The next one, Salsa Wheel.
Yes. How to effectively communicate very specific or narrow scientific findings, especially when it's hard to show their direct relevance to the general public or connect them to everyday concerns. I think most likely a lot of research that's done is very easy to connect and you have to find the dots. This is because unless you're working on mathematics or quantum theory, there you might find a challenge in the start that if someone is working with stars or astrophysics, it's very difficult to connect with that. But if it's your interest, you still can write on it. You can still find some public who has interest in this kind of area. But most likely, a lot of research should have a connection because any research is funded with respect to human. So any human improvement that you want to see, governments fund those research, right? So you can actually make a connection. It's very hard, but that is very important part for us to take care of. I think if you learn how to do this, you can actually learn to write good papers, scientific papers as well.
Okay. I think we have taken quite a more question. If anyone else has any question, you guys can raise hand. Otherwise, we are quite reaching up at the end. And that's okay. I think we have had most of the questions and the session. Okay, so following up on Maheera, could you please take one more question? I think it's like nanoelectric, nanoparticles. It is in the chat.
I can see, yes. I'm just reading. Talking about nanoparticles. So there are cobalt oxide nanoparticles that cause oxidative stress and inflammation in cells, but there are researchers where green synthesized cobalt oxide nanoparticles have shown antioxidant properties, which makes it conflicting to use such nanoparticles in research. Which should we use? Which should we use? Should we use such in our research? So so there are people have shown cobalt oxide, and some people have shown some green synthesized cobalt oxide. I think the easier way to go forward with this is like inform that people are trying to use nanoparticles to treat cells and stress in to treat stress and inflammation in the cells. In this case, people have reported cobalt oxide and synthesized cobalt oxide to treat it. What's the property of cobalt oxide? What's the property of synthesized cobalt oxide? So I think the important thing here is कि अगर आपने general audience को ये treat करना है, तो you have to focus on there are some nanoparticles out there that can treat antioxidant properties. Cobalt oxide or synthesized cobalt oxide is a scientific term again. So it's possible that you focus how the field of nanotechnology is actually improving the antioxidant properties. So, and then you can use these terms. Of course, you can use these terms. These kind of oxide information might be there for a lot of engineers out there that can understand. And I think it's an okay-ish information to share. It's not very in-depth.
That was interesting question. Okay, one more above of that, following up on Bushra's question, if you could say about nanoelectronics.
I cannot see. Okay, sorry, I can see.
Okay.
Yeah.
Okay.
There are any examples nano being used in our daily lives right now or not? Can we expect nanoelectronics in the near future? Nanoelectronics are used actually daily life everywhere, in your mobile phones, in your laptops, everywhere. So we are only using nanoelectronics right now in the world. We are not using microelectronics, or we are using microelectronics, but we are not using different scales. So nanoelectronics means electronics in nanoscale. Microelectronics means micro scale. So different scales, meter, nano, micro, pico. So we are using a lot of them around the world, and we've been using it for a long time now.
Okay, I think that really went very interesting. If anyone else has any question, you guys can ask. We have 3 to 4 minutes, but I guess we have had a lot of them. Okay, so since we are getting to the end note, thank you, Maheera. Thank you for taking out time, and thank you for all of us for having this wonderful opportunity to interact with you, and such an amazing presentation, and specifically getting into from an engineering and science perspective, that is very rare to find these days. So that's why, and you have always been very collaborative with Scientia, and so thank you, Maheera. Thank you for your time. We would like to reconnect again, and thank you.
Thank you so much for having me. I hope it was informational for everyone, and it was lovely to engage with everyone. That was very interesting questions. I like them, and always happy to help with the Scientia, of course. Okay, so we are ending, right?
Thank you.
Bye-bye.
Thank you.
Bye-bye.